The objective today is to write linear equations using slope-intercept form. Yes. All right. So we are starting topic 2, which means that this topic is all about like linear equations, which means you need to be comfortable with slope-intercept form, which is something that you have learned before. So I'm really hoping that we're just like dusting off the cobwebs and getting back into that practice of recognizing if something is in slope-intercept form, graphing them, writing the equation from a graph, using it to model real-world situations. So all of that is something that you will be tested on. Also, like tomorrow, you'll be tested on it for your exit ticket. So I'm recording right now. I'll have it posted in the slides this afternoon. If you have been absent for any day or extended period, make sure that you are watching the videos. There's no way for me to catch you up on everything that we've learned for the 2 weeks that you were gone, even if it was for a valid reason. There's no way. But luckily, I record everything and I put it in there. So watch it. I'm not saying you have to watch the whole like 45-minute video, but just watch enough to where you're able to do the practices. All right? Because you're still going to take the same test that everyone else took. Unfortunately, I can't remove standards and pass you just because I like you, right? You have to take the same test and pass it like everyone else. If you are struggling with this is a really important lesson. So here's some helpful videos from last year. So it's just in the link from the slides. Helpful videos from last year. Make sure you check them out. And you picked up a worksheet today. The one that is your homework is the one with the 6 grids in the front. All right, so that one is your homework, the one with the 6 grids. After today's lesson, you should be able to do the entire front side. Maybe after tomorrow's lesson, you'll be able to do the back side. So it's homework over 2 days. So do some each day, so that way you're not doing it all on the day that it's due. And then you'll upload it to Schoology when you finish. If you've been absent, or if you were absent on Friday, just FYI, I will be pulling you tomorrow from class lecture to take your test. So that's your fair warning. All right, tomorrow you are taking your test if you were absent Friday. Reminder that it is not an open note test and you have 55 minutes to complete it. So just one class period. That'll be tomorrow again, and I'm hoping that for everyone I'll have it graded by this Friday, but I have like 180 to grade. So be patient. That's all I can, that I have to grade them. Here's the schedule for the assessments for topic 2. And also if you look at the board on the side, so everyone look at that board. Side wall. When is topic 2 test scheduled?
17th.
Good. Next Friday on the 17th. So this is a really short topic, right? The first topic took us like 5 weeks. This one should really only take us 2 weeks because there's only 4 lessons. So that means there's 4 entrance/exit tickets depending on when we get to them. And then the topic 2 test. Binder check will be that following Monday. And then even though this is still a ways away, I want you guys to be aware of the deadline for late work from the pink folders, which is October 1st. So that's still a ways away, but I like for you to know all the dates in advance so you can prepare. Questions? All right, so then we're gonna look at the note sheet. Now the note sheet is the one that's not your homework, so it's the one with like the 3 grids in the front. All right, it doesn't look exactly like what I have up here, but they go together. So you just have to pay attention to where we're at in the notes to figure out where you're supposed to be writing stuff. So over here, we have some vocab. That's what you fill out in the vocab section. So you should see something that says slope-intercept form, you see it? And then like a blank space next to it. You'll have the correct paper in front of you, the one with the 3 grids. Not that paper. That one. And start filling in these definitions. So, and while you're writing them in, listen. So these formulas I will not be providing for you on an exit ticket, on your test. These are stuff that you have to memorize. And you really should memorize these just because you've seen it before and because you're going to keep seeing it throughout the rest of the semester. So really know slope-intercept form. That's your y equals mx plus b. Because you can clearly see your slope and your y-intercept. What does the m represent? It is a variable, but what does it represent?
Slope.
Your slope. So after you write y equals mx plus b, draw an arrow to the m and write slope. What about the b? What does the b represent? Y-intercept. Good. So then draw an arrow to the b and write y-intercept. So when I write stuff in slope-intercept form, like let's say y equals 4x plus 2, right? My slope would be m, or my slope would be 4, and my y-intercept would be 2. Right? We normally don't replace the x and the y with the numbers, but you do need to know what they represent. Anyone know by chance?
X has 2, X, Y, Z.
So here, I'll tell you. This is usually hard for kids to remember. So x, y, like in coordinate form, this is coordinate form, is any point on the line. So write that down in the free space next to slope-intercept form. X, y is any point on the line. All right, that will be useful later. X, y is any point on the line. All right, now this is where it gets like a little more specific about what slope and y-intercept are. So y-intercept, think of like intercepting a football or intercepting a pass, right? You're catching something. So the y-intercept is where the line catches or touches or crosses the y-axis, like in the name. So y-intercept is where it crosses the y-axis. Miss Medina. Hi. He is. Sure. Hold on. Find something down here. All right. All right, so where it crosses the y-axis, good there? All right, now the slope, I don't know if you were able to see this earlier, so if you didn't write the slope in, write it down now. In the chat. All right, you guys know I am recording right now, right?
Yes, yes.
If your parents want to know why you have bad grades, I can just show them what you do in class. All right. So as I was saying, slope, here's a formula. There's actually a bunch of different formulas. But here's one of them. It's y2 minus y1 over x2 minus x1. No, I do not provide you this formula. You do have to memorize it. But here's a few other ones that you might recognize for slope. We have rise over run. we have change in y over change in x. So yes, a triangle is actually a delta. All right, so delta means change in. So change in y over change in x. And which one you use, honestly, just depends on what type of problem you're dealing with. So if I'm telling you to find the slope between 2 points, and my points, it could be like 3, 2, and 4, 7. All right, then I would use this formula. If I'm using rise over run, what do we normally use that for?
X and Y.
Try again, that's not what I'm looking for. Well, obviously for slope, but for what type of problem? For graphing, good. So if I'm using rise over run, it's probably because I'm dealing with a graph. All right, and then change in y over change in x. I'd probably use that more for a table. So like 3, 2, 4, 7. Right, that's when I would use that one. And it'll make more sense as we do some examples. But any questions? All right, so let's look at our first set of examples. Actually, this is in your workbook, so take out your workbook and open it to page 27. Yes, page 27 of your workbook. Then, for example, like this one, we have Alani who wants to buy a bicycle for $360, and she has 2 different payment options. So she could make a down payment and then split it up over 5 weeks equally, or she can do 6 equal payments over 6 weeks. 6 equal payments over 6 weeks. That you don't have to fill in, but just for like comparing states, I'll write that down. All right, it's all in the information on that problem. A good test question would be to have you write a equation in slope-intercept form that models the situation. All right, now in slope-intercept form, what letters do we normally replace with numbers? Oh, x and y we don't normally replace with numbers, we replace
M
and b. All right. Sometimes we put numbers in x and y if we need to like solve for m or b, but normally we just replace m and b. So I need to find slope and y-intercept, but related to like these real world problems. So for option A, let's look at that first. Does it say what, like how much her down payment is on that one?
No.
It just says that she's making one, right? Now I'm just gonna throw out a number. Let's say that her down payment is $100. If it's $100 down payment, how much does she have to pay over the 5 weeks left? Well, how much did the bike cost total? Read the problem. $360. So if her down payment is $100, how much left does she have to pay?
$260.
$260. Now, if she's paying that over 5 weeks and she wants it to be equal payments, how can she figure out how much she needs to pay each week? 260 divided by 5. Notice when we have like slope and y-intercept, which one of these is normally a fraction? The slope or the y-intercept? The slope. All right, so that kind of gives you a clue there. But what's 260 divided by 5?
52.
52. So that's what she's paying each week, right? If I want to write this in slope-intercept form, what would be my slope out of these four numbers? So the slope is 52. 52, good. So that's the rate of change, right? That's what she's paying each week. At a constant rate, your slope is always what's at a constant rate. And then what would be my y-intercept? Do I have one?
No.
Don't you start at 260? Or no, 100.
My y-intercept would be 100, good. So what she paid initially is our y-intercept. Because your y-intercept will be something that you start with. All right, so any like situation that I give you, whether it's like buying a bike or what else could we start with? Paying a flat fee for roses, right? That will be your y-intercept. Does that make sense?
Yes.
So if I told you what does the slope mean in this situation, what would you tell me?
52.
And that is it is a slope, it's the amount she's paying each week, right?
Yes.
And then if I asked you what does the 100 represent, you would say
Down payment.
the down payment or your y-intercept.
Let's go.
You know, that's how the question will be on your test. Make sense? How would you write it for option B, the equation? So first, let's actually talk about this because we didn't yet. If it's 6 equal payments over 6 weeks, is there a down payment? No. All right, so no down payment. And that means that it's $360 over 6 weeks, so 360 divided by 6. How much would she pay each week for that one? 60. All right, now how can I write this as an equation in slope-intercept form?
60x plus 360.
60x plus 360?
Yes.
No,
It's just 60.
just 60x. Because remember, your y-intercept is like what you're starting with, right? So like we don't have a down payment this time. So if I needed to put a number there, what would I say is my down payment?
0.
0. So my y-intercept for that one is 0. I don't. Oh,
No. I have something.
all right. But does this make sense? So if I ask you, what does the slope in this option represent? What does it represent?
How much you pay each week?
How much he pays each week over 6 weeks. Or it's a girl, but questions? All right, so just make sure we know how to model these real world situations. For part B on your paper, it says like, how can you represent it? So let's represent it with a graph. Just kind of sketching it out. All right, so if this is my equation for option A, and we do have a y-intercept, let's just say 100 is around here, so it's not at 0, it's at around 100. What would the line look like for this problem? Would it be like curved, U-shaped, would it be straight?
Straight.
It would be straight, right? Because it's going up or down at a constant rate. That's what all of these linear equations will look like. A straight line. We'll get to these ones, I think, next semester. All right, so that's for this one. For option B, where would my graph start at? So like over here, we started at 100 for our y-intercept. It would start at 0 over here because you don't have a y-intercept, or if you do, but it's 0. Right, she didn't make a down payment on that one. Would the line still be like a straight line?
Yes.
Yes, it's still making equal payments over a similar amount of time. All right. So questions. All right. I'm gonna move on to some more simple examples. So this is the modeling examples. We're just gonna look at the note sheet from now on. So we're done with the workbooks for right now. All right. So on your note sheet, yes, the one with the 3 grids. Find the 3 grids, not the 6 grids, the 3 grids. Yes, thank you, Marcus. All right, this is what you're gonna put for teacher example. And you don't really need to write the whole thing. You can just write this part. Maybe not the question mark. All right, and I'm more of like a step-by-step type of person, so I'm going to give you some steps. Try to find somewhere on your page to write them. All right, so for step 1, first thing you want to make sure of to be able to graph equations is to make sure it is in slope-intercept form. So find somewhere on your paper to write this, maybe on the back side, maybe in your workbook, I don't know. But make sure it is in slope-intercept form. All right, make sure it is in slope-intercept form.
Writing these steps are part of your notes.
All right, so is this example in slope-intercept form? Does it look like y equals mx plus b?
Yeah.
Yes, so that's easy then. We just move on to step 2. First, make sure it's in slope-intercept form. It is, so we can move on. The second step is going to be identify and plot the y-intercept. All right, so step 2 is identify and plot the y-intercept. So in the equation that I highlighted, what is the y-intercept?
Yeah, the 2.
The 2, good. So that's what is in the place of the b. Right, and is it a positive 2 or a negative 2? Positive, so you can use this as your guide, right? It's normally positive in the equation. So if it's positive here, it's a positive for your y-intercept. All right, now before I plot this, we really need to make sure that we understand like how these coordinate planes work. So pay attention, even if you think you already know, because some kids have been doing it wrong their whole lives. All right. Is the vertical axis or the horizontal axis the y-axis? Should hear more than a few people. Which one is the y-axis, the vertical or the horizontal line?
Horizontal.
It's the vertical. Here's how you can remember. Y goes to the sky, right? Y goes to the sky, so it rhymes. Up and down is your y-axis. To help you remember the other one, the x-axis, you can remember it as x goes to the left and the right, but this one x goes to the left. Okay? So if I need to plot my y-intercept, I need to put it on the y-axis. So start at the origin. What's the y value at the origin where they cross?
0.
At 0. So up, positive or negative?
Positive.
Positive, and then going down would be negative. So I need to go from the origin up to plot my y-intercept. Good there. So plot your y-intercept at 2 for the y-axis. And then we're going to do step 3, which is to use rise over run to plot the next point. All right. So use rise over run to plot your next point. Rise over run is what? It's your slope. What's my slope on this one?
2 over.
4 over 5. Now the sign affects your rise. So is this a positive or negative?
Positive.
Positive. So does that mean I'm going up 4 or down 4?
Up 4.
Up 4. So from the y-intercept that you made, go up 4. 1, 2, 3, 4. And don't make your dot yet, because you have to do your run. And your run is always going to be to the right. So how much to the right am I going? 1, 2, 3, 5. All right, and then make your other dot. Now, you really only need 2 dots, but we'll just throw in a third so that we can make a really straight line. So going up 4 to the right 5. And then connect your dots, draw your arrows. What do the arrows mean? That it goes on forever, right? So unless it tells you that it stops, make sure you draw your arrows. Questions? All right, the next one is going to go faster. So this one I really broke it down. The next one kind of faster. All right, so next page. This will go under the class example, so make sure you write this part down because that's not included on your note sheet. This goes under your class example. All right, now we're going to graph y equals -3/4 x minus 5. So first thing, check, is it in slope-intercept form? Yes or no?
Yes.
So good. Now move on to step 2, which is to plot your y-intercept. So what is my y-intercept in this one?
-5.
Good. Glad you guys remember that negative. So my y-intercept is -5. Does that mean that it goes over here?
Yes.
Does it?
No, it
No.
goes down
Down.
below. Down the what?
Where did I plot it accidentally?
On the
On the
X.
x-axis.
Good. You need to plot your y-intercept on your y-axis. So I see kids do that all the time. So don't make that mistake. So from your origin, are you going up 5 or down 5?
Down 5.
Good. So 1, 2, 3, 4, 5. All right. Now third step. Use your rise over run to find your next point. What's my rise over run?
-3 over 4.
-3/4. Now notice in the example, it has the negative sign like in the middle. All right, the placement of it doesn't really matter. It can be in the numerator, it can be in the denominator, but the sign only affects your rise. So just get in the habit of writing it like this, where if it's negative in the numerator or denominator, just rewrite it in the numerator. So if you're doing a problem and you get something like this, just rewrite it like this. All right, because your run always goes in what direction?
Up or down.
Your run.
It goes to the.
Your run always goes to the right, so the sign doesn't matter, but the sign affects the rise. Make sense? All right, so am I going up 3 or down 3?
Down 3.
So from your Y-intercept, go down 3. And then am I gonna go left or right 4?
Right 4.
Always to the right for your run. 1, 2, 3, 4. All right. And then from that dot, go again down 3 to the right 4. And then connect the dots, draw your arrows. Sorry, it's hard to draw a straight line. All right, questions there? All right, so I'm going to give you one to try. So I'm going to switch this here momentarily. All right, this is your student example. He's right here, Sarah.
No, that's not over there.
You know what? That's a doing.
Got it. Yep, they're there. Thank you.
Check your work compared to mine. All right, make sure that your Y-intercept is at -2 on your Y-axis, not on your X-axis. This would be wrong if you have it there. Don't put it there in the blue. Make sure that you're going up 2 and to the right 3. All right, did we go up 2 to the right 3 on your own paper?
Yes.
And did you fix it if you did it?
If you did it, just fix it.
All right, so that matches up. A good test question on a side note would be to have it written like this. Y equals -2 plus 2/3 x. And then me asking you, what is the slope? So don't look at this one. Look at this one down here. What's the slope over here? It's not -2. It's 2/3 still. So remember, don't just memorize it by order. M is always the number that's in front of the x. All right, so slope is 2/3. What's my Y-intercept in this one? -2. So that should be easy points on a test. Don't let it trip you just because of the order. Questions? All right, and then just because we didn't do an example like this, and I know there's some on your practice, so this is completely separate from this problem. If I have, let's say y equals 4x plus 7, and you need to graph it, the slope isn't a fraction in this one. What's the slope in this one? 4, because it's the number in front of the x. So if I need to graph it, what do I put for my rise over run? 4/1. All right, so all whole numbers can be written as a fraction, just put a 1 underneath it. So the run isn't 0, still has a run, it's just 1. Questions? All right, that's just completely unrelated to this example, just so that when you get to your homework, you know. All right, next one. So on the back side of your notes, find this problem. We're on the back side now. All right, we did a lot of graphing, so you should be able to do all the ones on your practice tonight for graphing. These are for figuring out, stop talking. It's for figuring out the equation from a line that's already graphed. Normally it doesn't have all this stuff that's around it. All right, so just kind of ignore everything that's not the line, just look at the line. First, what is slope-intercept form? Y equals mx plus b. So if it wants my answer written in slope-intercept form, what two things do I need to identify? The slope and the y-intercept. The order in which you identify them doesn't really matter. You can start with y-intercept first, just because it's easier on a line. So over here, don't say it out loud yet, just look at it. And think about what your y-intercept is. Just think about it. All right, it's where the line crosses the y-axis. So what is my y-intercept? You can say it now. It crosses the y-axis here, which would make the y-intercept 1. And is it positive or negative 1? Positive. All right, so it's like between 0 and 2. That makes it 1. Or B. All right. That part's usually easy, just where it crosses on your y-axis. The M, we do have to do a little more work for. So we can use any of the formulas that we wrote down on the first page. I'm just showing you real quick. On the first page, we wrote down all these different formulas. So we could plug in like 2 points into that first formula. Or we could count the rise over run. Which one do you think will be easier? All right, I think so too. When you have a graph, it's usually just easier to count your rise over run. That's what we'll do here. So to count your rise over run, you're going to want to look for 2 points. It can be any 2 points on the line, but you're going to want to be like methodical in how you pick them. So you're going to want to pick points that go through like what I call a crosshair. You guys know what a crosshair is? Kind of. It's like when you're playing like shooting games, or if you actually like go shooting, like a crosshair.
Right through the graph, like the box.
Yes. So when you're shooting, whether it's in a game or in real life, do you want your target to be like at this near the crosshair?
No.
Yeah.
No. You want it to be right in the middle of your crosshair, don't you? So when I'm picking my points on the line, I want them to go right through the middle of the crosshair or a grid. So I can pick this dot and this dot over here. Don't they both go through crosshairs? So I'd be wise to pick those. All right, once you've identified 2 points that go through a crosshair, draw a triangle. All right, so you don't necessarily have to draw a triangle, but this is a really good way to count your rise over run. So connect them with a triangle and then count your rise. So like how much am I going up or down to get to the next point? I'm going down 1, 2, 3. And since I'm going down to go from this point to that point, is it going to be positive or negative 3? Negative. So it's like when you're reading a book from left to right. I have to go down 3, so it's going to be negative 3 to get to that one. All right, now how much to the right do I have to go? 4. So go to the right. 1, 2, 3, 4. And then put it together. What's my rise over run?
-3/4.
-3/4. So then to wrap it all up, write it in slope-intercept form. We said slope is what? -3/4. X plus your y-intercept, which is 1. All right, questions? All right, so that one's just counting your rise over run. The next example, this will go for your class example. Now you don't have to write the entire thing. I'll highlight what you need to write. But we have, how can you find the equation of a line that passes through 2 points if neither one of them is the y-intercept? Consider the line. So we're gonna put the line that passes through the points -1, -2, and 3, 4. All right, that's what I highlighted is all you need to write. At least for right now, or whatever I write. So for this one, can I use the rise over run formula? Would that be effective in this one? No, because I don't have a graph already made. Could I make a graph if I wanted to?
Yeah.
Yes, but that's a little bit more work. I don't have any graph paper on me. So we're gonna use a different formula. What formula can we use? It is a slope formula. Which one though? y2 minus y1 over x2 minus x1. All right, because we have 2 points. That's all we need to be able to find everything else. All right. So here's how you use this formula. Just pick one of your points to be x1, y1. Does it matter which point you pick?
No.
Does not matter. So I'll make this one x1, y1. The other one can be x2, y2. So label them first. I still label them. I don't skip this step even though I teach it, right? Label them first. And then it's just a matter of plugging them into the formula. So if I label them like this, what are we saying that y2 is? 4. Here, I'll tell you something. 4. And then it's going to be minus y1. What did we say y1 is? -2. Over x2, which is x2 is 3, the way that I have it labeled up here. And then x minus x1, which is -1. So you see how you plug it in exactly how it looks into the formula? Even though this is like a little bit ugly, you plug it in exactly how it looks. What happens with these double negatives? They become positive, right? Because remember, you add the opposite. Remember that? Add the opposite. What's 4 plus 2?
6.
Good. And then add the opposite on the bottom. What's 3 plus 1?
4.
Good. We're almost there. Am I allowed to leave my slope like that, a 6/4? It can be a fraction, but we want it to be a simplified fraction. How can I simplify this? On each side, good. So divide by 2. What's 6 divided by 2? 4 divided by 2. So my slope is 3/2. Questions? Now, does this answer the whole question about finding the equation? No, so what else do I need to find to make this slope-intercept form? To make this y equals mx plus b. We found the slope. What do we need to find? The y-intercept. All right, so we found the slope. What did we say the slope was?
3/2.
3/2. So I'm gonna put that in place for the m. Now, we do have enough information, maybe you just can't tell right away, but we do have enough information to figure out what the b is. Because what did I tell you that the x and y represent? Look at your vocab section. I know I told you to write it. Maybe you did, maybe you didn't. What does the x and y represent?
On the line.
Any point on the line. So since it's any point, and I have two options here, does it matter which one I pick? It does not matter. Personally, I like working with positive numbers, so I'm gonna pick that one. And just plug it into here. What's my y?
4.
What's my x?
3.
Good. And then plus b. And now that that's all plugged in, I can actually start solving. Does that make sense? All right, so don't lose sight of how to solve. You guys know how to solve these. First, what's 3/2 times 3?
9, 6.
Close.
And then multiply the top.
9/2. So it's 3 times 3, and then if you really think about it, 2 times 1. So 9/2 plus b. How can I get rid of the 9/2?
It's a positive 9/2.
Oh, subtract 9/2.
You divide 9.
So if this was times b, then yeah, you would multiply it by the reciprocal. But since it's plus b, you have to think about what can I do to make it 0? Subtract it. So each side you're gonna subtract 9/2. And I don't like subtracting fractions, so I'm gonna use a calculator. What's 4 minus 9/2? This is how you enter it in your calculator, by the way. What is 4 minus 9/2? Put it in your calculator.
18.
It is not.
Oh, man.
Yeah, at least you tried.
Put it
You weren't trying.
in the parentheses. That's why I tell you guys to try it, because we can avoid this on the test. All right, once we put that in our calculator, we get b is -0.5. Put it all together in slope-intercept form. Y equals 3/2 x minus 0.5. All right, questions? So what I boxed is what is important. Like that answers my question. Everything is important. That's not what I meant. What I boxed answers my question. Don't pack up yet. My third hour did this, and I made them turn something in for points. So don't do it.
Okay.
I'm gonna give you one to try, and then you can chalk up at 109. Understood? All right. So this is your student example. Do not pack up early, or I'll make you turn it in. At 109, you can pack up. Work on this until 109.